Let's say you woke up one morning and thought, you know what? I'm gonna dig a hole through the earth today. Maybe you just got bored, maybe you're trying to avoid going to work, or maybe you're just very, very ambitious, so you grab your trusty shovel, walk into your backyard, and start digging. And digging. And digging. Unfortunately, a few meters down, you hit solid bedrock, melt your shovel magma, and enough pressure to turn you into a human pancake. But for the sake of imagination, let's say you have a magical drill, one that can cut through anything, rock, molten iron, even the Earth's core, without melting, collapsing, or violating too many laws of physics. You dig straight down, from your spot in, say, Kansas, straight through the Earth, all the way to somewhere in the Indian Ocean, a perfect, smooth tunnel right through the center of the planet. Now here comes the fun part. You jump in. At first, you just fall. Gravity pulls you toward the center of the Earth, just like it always does. But here's the twist. As you go deeper, the amount of Earth pulling you down starts to change. That's because gravity depends on the mass beneath you. The farther down you fall, the less mass is below you. So gravity gets weaker. By the time you reach the core, about 6,371 kilometers in, gravity is pulling on you from all directions equally. Which means, weirdly enough, you'd be weightless. Not floating in space weightless, more like, I'm stuck in the center of the Earth and don't know which way is up, weightless. But you don't stop there, because you're moving fast, really fast. See, as you fell, gravity was accelerating you. By the time you reached the center of the Earth, you'd be going at about 28,000 kilometers per hour. That's about 8 kilometers per second. That's fast enough to go from New York to Los Angeles in under 10 minutes. So even though gravity is now pulling you back toward the center, your speed carries you upward, toward the other side of the planet. Basically, you overshoot. Now gravity's working against you. It's slowing you down, just like it sped you up before. You keep rising, but slower and slower, until, right as you reach the surface on the other side, your speed hits zero. You stop, you hover for a second, and then you fall back in. Congratulations, you're now a human yo-yo. In a perfect vacuum, with no air resistance, you'd fall through the Earth back and forth forever, like a pendulum, over and over, falling through the core up to the surface, falling back in, endlessly bouncing between two continents. But we don't live in a perfect vacuum, do we? In reality, your tunnel would be filled with air, lots of it, and that air would be trying very hard to slow you down. At first, the air resistance is small, but soon as you reach higher speeds, it increases, a lot. So instead of zooming through the core, you'd slow down, a lot. You might make it halfway to the other side on your first trip, then a bit less the second time, and less again. Like a swing gradually losing momentum, you'd swing lower and lower each time, until eventually you'd come to a stop, right at the center of the Earth, stuck, forever, in the hottest, most pressurized, most unair-conditioned part of the planet, just dangling there. And even getting to that point would be a miracle, because there's another huge problem. The tunnel would collapse. The Earth isn't a rigid ball of rock. It's a layered mess of molten iron, shifting tectonic plates, pressure hotter than the surface of the sun, and gravity doing its best to squish everything back together. Your magical tunnel would need to somehow resist millions of tons of pressure from every direction, and even if you could keep it open, you'd need to keep it cool, which is hard when the temperature in the core is around 6,000 degrees Celsius. That's hot enough to melt iron. Or your shoes. And let's not forget the small issue of magma. You'd be falling past underground oceans of lava, pockets of explosive gas, and who knows what else. One small leak and your tunnel becomes a lava fountain. Or worse, a steam-powered rocket shooting you into space. Okay, that part might actually be fun. But wait, let's assume you did it. You built a perfectly vacuum-sealed, reinforced, temperature-controlled tunnel through the planet. You jump in, you bounce back and forth, And after many trips, you stop in the middle. Now what? No ladder, no rope, just you, suspended thousands of kilometers below the surface, completely weightless, surrounded by thousands of degrees of molten pressure. Hope you brought snacks. Oh, and did we mention that the Earth rotates? Yep. While you're falling, the surface of the planet is spinning. In Kansas, for example, it's rotating at about 1,400 kilometers per hour. On the other side of the world, it's spinning the opposite direction at the same speed. So unless your tunnel somehow compensates for the Earth's rotation, you'd smash into the side of it seconds after jumping in. Or rather, the side would smash into you. Basically, if the fall didn't kill you, physics would. So in the end, jumping into a tunnel through the Earth is a great way to experience crushing gravitational forces, terminal air resistance, death by magma rotational whiplash, and eventually eternal boredom in the center of the planet. But hey, at least it beats rush hour. Or rather, the side would smash into you. Basically, if the fall didn't kill you, physics would. So in the end, jumping into a tunnel through the Earth is a great way to experience crushing gravitational forces, terminal air resistance, death by magma rotational whiplash, and eventually eternal boredom in the center of the planet. But hey, at least it beats rush hour.